In this video, we're going to be talking about finding they estimate the slope of a tangent line, this exponential at a particular point. The problem is that we don't have the calc yet to do it. So we're going to be using a secant line and then talking about the definition of a tangent line to help us figure this out. We're going to use a calculator, and so we're going to have to do kind of the old-fashioned way, right? So we're going to be talking about slope of a tangent line. We'll come back to that. So let's first start to talk about that the formula for the slope is y2 minus y1 divided by x2 minus x1. So the slope of our secant line is going to be our equation, right? So that's our y2. So it's going to be 2 to the x minus, this is going to be our x1, y1. So it's going to be a 2 minus y1 divided by x minus x1, which is 0. So this becomes 2 to the x minus 1 divided by x. So that's our slope. All right. So that is our slope of our secant line. But we're going to be doing the slope of tangent line. And so remember the slope of tangent equals the limit. And as x is going to be approaching this 0, okay? Approaching 0 of our slope of secant. All right, so we're going to be doing the limit as x approaches 0 of this equation. So 2 to the x minus 1 over x. All right, so problem is right away, if I were to plug 0 into this, I'd have 2 to the 0, which is 1 minus 1, which is a 0, and then divided by 0. So 0 over 0. Not helpful. So we don't have a calc way to do it quite yet. So instead, we're going to get an answer, but we're going to need to use a table to make this happen. So we're going to use a table to. All right, so here's what we got. Our x values, and then our y values is the function. Okay, and we are going to be getting infinitely close to 0. So we're going to start off with 0.1. All right, so we're going to be plugging things into the calculator to kind of make this happen. So our fraction is, we're going to have 2 to a power. So our power is going to be 0.1 minus 1 divided by 0.1. Okay, that's going to get us a value. So we're going to get 0.7177. And then we're going to get closer. So we're going to insert a 0. Insert a 0. And so now we're getting a 0.6955, a bunch of values after that. We'll go 0.001, 0, 0. Okay, so it's still kind of hovering around that. 6933, blah, blah, blah. 0.0001. Insert 0. Okay, we're getting closer. 0.69317. Blah, blah. Maybe we'll just do 2 more of these. Okay, so insert a 0. Oops. Let's try it again. Insert a 0. All right, that's better. 0.6931 4. All right, so we'll do one last and we'll take it. That's about as accurate as we need to be. Okay, so I should have 5 zeros. There we go. So 0.6931 4. Right, at least 5 levels of 5 decimal points of accuracy we're sitting at. So what is our limit? We don't have the calc yet to do this, and so kind of this was our best option. Us doing a limit, we're getting closer and closer and closer to 0, so that's just us plugging in values, getting infinitely small, which is basically getting infinitely close to 0. And we got a value of 69314, at least that amount of accuracy. And that is our slope at that point. Right, so if we graphed this and we kind of basically drew a slope on it, that's roughly the steepness to this slope. All right, so that was, at least so far, we're going to try to find a tangent, slope of a tangent line, and we don't have the calc quite yet to do it, so we're going to do the slope of a secant line, which the slope of the secant line is really the limit as x approaches that x value. Right, if that was a 5, then we'd be getting closer and closer and closer to 5, so we get a 5.1, 5.01, 5.01, on and on and on and on. But we were approaching 0, right? Right, that covers that.